Hello everyone, welcome back to Tales of Chemistry. Today, let us learn about electrochemistry. This is class 12 chapter in ISC. Electrochemistry is the branch of chemistry which deals with the relation between chemical reactions and electricity. Chemical changes and electricity, the relation between these two is explained in electrochemistry. Electrochemistry deals with the study of electrical properties of solutions used in electrolysis and also the chemical changes brought about by electrical energy. Electrical properties of solutions as well as the chemical changes which takes place because of electricity. In our syllabus, we need to study about the construction and the working of electrochemical cell, or which is also called a galvanic cell. Now, let's see what is a galvanic cell. It's a device in which electrical energy is produced from chemical reaction. So keep that underlined. Device in which electrical energy is produced from chemical reactions are called electrochemical cell or galvanic cell or voltaic cell. Let's see how is this constructed. Galvanic cell is made up of two electrodes immersed in solutions of their respective salt. So let's study this. Let's analyze this diagram here. On one side, let me call one half reaction. On one side of this galvanic cell, I have taken a zinc rod, Zn rod, which is immersed in 1 molar solution of ZnSO4. 1 molar solution of ZnSO4. On the other side of the same galvanic cell, I have taken a copper electrode which is immersed in 1 molar solution of copper sulfate. 1 molar copper sulfate solution. So, I have zinc in ZnSO4 solution, copper in CuSO4 solution. Okay, now to connect these two solutions internally, as in, ZnSO4 solution has got no contact with CuSO4 solution. Now, to connect the two solutions, we are using a salt bridge. The apparatus that you can see here, that is called a salt bridge. Okay, the function of salt bridge here, main function is it connects the two halves or it completes electrical circuit. One more advantage or one more function is there, which we will discuss a bit later. So, first advantage of salt bridge is it completes the electrical circuit. Salt bridge completes the electrical circuit. Okay, now what is taken inside this salt bridge? Fine. In the salt bridge, there is one electrolyte, something like KCl. Okay, and agar-agar. Agar-agar is a gel-like substance. Agar-agar dissolved in hot water gives us a gel-like substance. So that is agar-agar. And in that we are taking KCl solution. So what works here, what we need is KCl solution. In fact, the K plus and Cl minus ions is what we need. Okay, so that is regarding salt bridge. Now let's see what are the reactions that are taking place in this. So on the left hand side where you have zinc in zinc sulfate solution, fine. The spontaneous reaction which is taking place here is a zinc rod ionizes or it gets converted to Zn2 plus. It moves into the solution in the form of Zn2 plus. Also, it releases two electrons. Now, point number one. The process which takes place here, zinc becoming Zn2 plus. This process is called oxidation. And the electrode at which oxidation takes place is called anode. Zinc becoming Zn2 plus processes oxidation. The terminal at which oxidation takes place is anode. On the other side, the spontaneous reaction is Cu2 plus copper ions from solution, okay, taking up two electrons and it becomes Cu metal, or I mean solid. Yeah, Cu atom, copper atoms are produced, copper ions become copper. This process is called reduction, and the terminal at which reduction takes place is the cathode. Okay, so in a galvanic cell, at the anode there is oxidation, at the cathode there is reduction. Now, from where is our copper ions receiving these two electrons? The two electrons which are deposited by Zn atom, that is moving through that external circuit or the external wire, and it reaches the cathode. So the flow of electron is from anode to cathode. Flow of electrons is from anode to cathode. Electricity will be flowing from cathode to anode. Now, in the diagram, what more you will see is a switch or a key, whatever you call it, and a voltmeter. So, purpose of key is known to all of us to keep the circuit on, and voltmeter is to know whether electricity is actually flowing through the wire. All right. So this makes a galvanic cell. What we have studied now is called a galvanic cell. Now, functions of salt bridge. Only one function I have mentioned as of now, that it completes the electrical circuit. What is the other function? Well, if you see, when zinc produces Zn2 plus ions, in this 1 molar ZnSO4 solution, you are adding more and more Zn2 plus ions. You are adding more and more Zn2 plus ions. That means the concentration of positive ions are increasing in ZnSO4 solution. At the same time, on the other side, you are consuming Cu2 plus ion. Cu2 plus is becoming Cu. So the concentration of Cu2 plus ion is becoming less at the cathode side. Therefore, the left side solution is rich in positive ions. Right side solution is rich in negatively charged ions. Salt bridge will be sending oppositely charged ions to each of these terminals. I mean to say, on the left side container, you have more positive ions. So from the salt bridge, Cl minus ions will be moving towards ZnSO4 solution, and K plus ions will be directed towards CuSO4 solution. Thus, the electrical neutrality of the two half cells are maintained. That is the second function. Salt bridge maintains the electrical neutrality. It maintains the electrical neutrality of two half cell solutions. All right, that's all about the construction of galvanic cell. Now let us see the cell representation. What is a cell representation? So in cell representation, you need to write the anode ions, salt bridge, cathode ion, and cathode material in this order itself. So in the above cell, the cell which we discussed, there is zinc at the anode. What is the physical state of zinc? It is in the solid state. Then the ions available adjacent to Zn is Zn2 plus ions, right? And the concentration of the solution we mentioned was 1 molar. Salt bridge is represented by two lines like this, after which the cathode ion has to be written, not the material. Cathode ion, Cu2 plus, concentration was 1 molar. Then the material of cathode and its physical state. So this is how we represent the cell. Now, you cannot change this order. It has to be written in the same order with the physical state of the electrodes, also with the concentration of the electrolyte solutions. 1 molar ZnSO4, 1 molar CuSO4 was taken. That's why that 1 molar is written. So that's all about constructing a galvanic cell and also the cell representation. The cell which we constructed now is a simplest possible galvanic cell, which is called the Daniell cell. All right. Thank you for watching.